It's sort of raining here, so I want to bring the doggy in.
Mm-hmm.
Steve, come here. Steve, come here. Let's turn off your light. Okay.
Hi,
Hello.
Hi.
how are you all?
Hey, okay. And you?
Not bad for a fat kid, and yourself?
Ditto, I'm sure. Yeah. Oh. Let's see. I think I got my astronomy notebook. So I know it's 8 o'clock. You just had your first lunchies. You want your second lunchies? So yeah, so if they're so damn smart, why can't they bring down their rocket like Elon Musk does?
Yeah, great question. But to be fair, when I first, I was fortunate enough to watch the Falcon Heavy launch and the boosters come landing down. And I am still stunned that they were able to do that, to land the boosters precisely in the space they wanted to.
Yeah.
You're talking about
was, what,
are you talking
2018?
about the
SpaceX.
Elon Musk SpaceX thing?
Yeah, that's what I'm talking about. Yeah, the Falcon
Yeah.
Heavy.
So
But
what
the
are we looking at with
Chinese-
the Chinese this weekend?
So yeah,
Well, that's-
different country. I don't know what they're up to. I have no clue. But apparently, and this is like concerning to some people, we have no idea where it's going to land. We just know that it's probably going to be in between 41.5 degrees north and 41.5 degrees south.
And we're at what are we at? 43, 47?
We're a little higher than that. Yeah, we're a little higher than 41.5.
It'll land
Yeah.
in Central Park.
Yeah, it could be.
Oh, this is
Yeah.
going to be very interesting. There's a lot of water there. That's the good news.
Yeah. Yeah.
But
But the Chinese didn't want to work on the on Elon's technology, huh?
Yeah, I don't know. Really don't know what China is, their rocket programs are like, but here, this tweet that came out, the most probable re-entry time is going to be on May 9th, and there's an uncertainty window of nearly 6 hours, which is kind of crazy.
uncertainty of 6 hours, but what's the uncertainty location?
Uncertainty location is huge. It's on this map here, so it's anywhere in this red band.
Wow.
I'm thinking of a tumbling, irregular shape that is partially burnt up as it comes down, and it would make for a 6 hour, semi-unpredictable time frame.
Mm-hmm.
Well, it's not going to do as much damage as the asteroid would have done in Armageddon.
That's exactly right. Yeah, I think it's funny. Oh, not funny. It's just a coincidence that the movie we decided to watch is lined up with current events like this.
Yes.
Where things are going to be falling from the
Absolutely.
sky unexpectedly.
So in Armageddon, the size of that, which was much bigger than what done in the dinosaurs, would have, as they said in the movie, destroyed all life on Earth.
Right. Yeah. So I forget the size of the meteor.
The size of Texas.
Texas sized. Yeah. So we're talking a few hundred miles in diameter.
Right. And the one that killed in the dinosaurs was only 10 miles or?
Yeah, it was about 12 miles.
Yeah.
Yeah, so like the size of Manhattan.
Mhm.
And that's a excellent point for the meteor that wiped out the dinosaurs, the last major extinction event, is something I want to touch on today. I found, just incidentally, a really cool YouTube video that somebody had uploaded, and it's a simulation of what the dinosaurs would have seen 67 million years ago.
I mean, not
Yeah,
like
yeah.
this.
Would have been frozen scared. It was the Chicxulub asteroid. I think that's the name of it.
Mhm.
Yeah. There is some debate whether it was the meteor or the volcanic hotspot of the Masserine Islands that India went over, that created the big basaltic plains, Ghats in India, as it was passing over this hotspot, and it left Reunion and Mauritius, and it could have been both. It could have been, all of the above.
Yeah, right.
But
And
anyway.
there's no certain way to determine, one cause and one effect, whether the asteroid itself was responsible for, exactly who went extinct that long ago. But we do know there is a crater, and you can see it plain as day on the map here. The Gulf of Mexico.
No,
It used to be a gulf.
that's not it. No,
It's not.
the Gulf is not it. It's off center to the Gulf, and underneath a good part to the south of the Gulf, to the Yucatan Peninsula.
Oh,
the
so
Gulf
like present
itself,
day Cuba?
you cannot see it. You cannot see it with your eyes.
No, I'm saying like the Gulf of Mexico was formed from the impact.
No,
It wasn't?
no,
Oh, okay.
no. It's off center and to the south, and is inland, and that southern bit of the Gulf of the Mexican coast and the Yucatan Peninsula. It's not that big. It's plenty big, but it's not that big, and it did not create the Gulf of Mexico. It's not that size. It's not there in that size.
Interesting. Like, well, then I guess if you have like a 12, let's say a 12-mile diameter impactor, like what would the scale of the crater be in that case?
I don't know that.
Well, like, what do you estimate the size of the crater would be? Like, because like from my knowledge from just taking astronomy as an undergrad, we learned that the crater formed by some impactor is at least 10 times the size.
Yeah, easily. Well,
Yeah.
Stuart's good for looking up things simultaneously, and look at the
Yeah.
crater in Arizona.
Right.
How
Yeah.
big was the impactor that created that huge crater? It's big, but it's
Yeah,
tiny compared to the crater.
Yeah, I mean, that sounds
What?
about right. I thought I saw something recently where they've actually gone down into that crater, taking
Arizona.
no, the
or-
one with the dinosaurs down in the Yucatan, and they've actually
Yeah.
gone down and taken. I thought we just saw this
Samples.
on Nova or something last year. They took stuff out of it that
Yeah.
showed exactly, the aging of it and where the meteor came from, and that
How
was all
deep
done
it
the last
was.
couple of years, I thought.
We
Yeah.
saw
They
that,
did like core
Deb,
samples.
we saw that
What?
on it was either Nova or National Geographic, but it was a great documentary about the process of digging down and looking at the composition of the, not the soil, but
Yes,
the earth
soil.
going down.
Yeah.
that they
How do you
brought up.
spell the chick? How do you spell it? CHIX.
Yeah, CHIXCULUB, I think.
Here we go. Crater. Okay. All right. So, impactor diameter.
You got the wrong group here, you know.
Apparently,
Well,
there's another crater called the Vredefort crater with an estimated diameter of 300 kilometers, is the
That's the
world's
one in
largest known impact structure.
in
It was
Russia?
I guess it was created when an asteroid measuring at least 10 kilometers landed an estimated 2 billion years ago.
Okay, so I don't know how to. I mean, I'm just looking on my phone, and it's half on like the Yucatan and half in
Right.
the Gulf of Mexico, kind of, and the area of the crater is 9,800 square miles.
Okay.
And it's located offshore near the communities of blah, 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 formed within a large asteroid or comet about 11 to 81 kilometers. So that's in diameter. So that's a huge range. And
Yeah.
it was.
Well, it brings me to this question because now I'm curious. What did form the Gulf of Mexico?
Oh, well, tectonics.
Tectonic plates.
Interesting. Okay.
Yeah,
Yeah, I guess that makes sense.
the tectonics of North America are really interesting. And you can learn all about it on May 14th when my geology friend gives a lecture about Eastern Greenland.
Interesting. Oh,
But it
all right.
won't tell you about the Gulf of Mexico.
All right. So that's a new thing I learned today because I was,
Yeah.
under the impression that it was something else.
Deb,
Yeah.
can I ask a
Well,
question? Are you
go ahead,
talking
Ryan.
about the tectonic plates where Scandinavia goes up into northeastern Greenland and the elbow of South America goes in towards South Africa, and then Africa goes in towards the northeast coast of North America.
And makes the Appalachians. Yeah, that's exactly it,
stuff.
Owen. Yeah. The
We-
Caledonian orogeny and yeah.
I mean, this is like reunite Gondwana land,
Yes.
not reunite, but that was a big T-shirt in Madison, Wisconsin when I was a student there. It was Unite Gondwana land.
Yeah. Yeah.
Gondwanaland. Yeah, I remember that. I did my I had to take a subject exam because I'm going to teach earth science at the end of the year in Florida, and that was one of the questions. We needed to be familiar with Gondwana.
Well, start with Rodinia and Pangea and Gondwana. Yeah.
Mhm.
The continents have come together and separated and come together and separated many times.
Right,
So-
exactly. Yeah.
And then but OAN has it right. But Florida is not part of that. A big part of that orogeny, of that coming together. That's more East Coast and Northeast and up as far as Greenland and Newfoundland, and then the Scotland and the Shetland Islands. They're all part of it.
You have to think of those places as an afterthought.
Mm-hmm.
A separation afterthought, because I don't know how it all happened, and I have never studied this thoroughly enough, but when you think about the way the continents would have fit in together as one landmass and then separated, and then the question is, why did they separate?
Well, that's a big question. What creates tectonics? Does it have to do with the circulation of the contents of the mantle? Where the hot spots come to play? Does it have to do with the physics of subduction, pulling things around? So there's apparently a lot of debate about what makes for tectonics.
Yeah, and I think it helps to know that Earth has a fluid mantle or semi-fluid mantle on which these plates can float and move around. And I think if it weren't fluid, like the moon has cooled off enough so that there really is no more plastic rock. You won't have any more movement on the crust. I think that's why Earth's crust is able to move, and some smaller rocky bodies in the solar system,
They don't
tectonic
have
plates are absent.
Yet they have volcanoes.
Yes.
I just heard a talk today from the American Museum of Natural History about volcanoes on some of the rocky moons of Venus and Mars and the moons of Saturn and Jupiter.
Is that the basis for the story in Armageddon? Was the fact that they had volcanoes and earthquakes and?
No, where was that asteroid supposed to have come from?
I don't. I think it just got knocked from the asteroid belt, right?
I don't know. I
Because
know it's not.
Some
It's
comet,
knocked little bits.
some
Stuart?
comet was involved, they said, right? Some comet hit something somewhere. I thought they implied once.
yeah. So I always have the plot pulled up here just so I can reference it quickly in case there's something I
Yeah.
forgot.
Yeah. Oh, so
so-
cocked.
Rogue comet that jarred loose an asteroid. So this comet went into the asteroid belt. So it actually unleashed a meteor shower. So not just that one asteroid, but a slew of tiny rocks that were coming towards Earth. And so the prelude is the meteor shower, and then the big world-ending asteroid is the Texas-sized one.
Yeah.
Just before we get off it, I just emailed all three of you the New York Times article from a few years ago about drilling in that, that crater down there in the Yucatan.
Yeah, I was actually just
Oh.
reading that now.
Yeah. So what is this thing that everybody wants to use a nuclear weapon to destroy things in space?
I think
What?
nuclear weapon might be the safest option, so that it doesn't explode accidentally in transit.
Powerful?
Or it could be more powerful.
TNT would explode in transit?
No, TNT wouldn't be as powerful as nuclear. I think this is a very good question, but I think that the nuclear power is the most powerful explosion we have ever, in the man-made world, ever created or done. But it's a good question.
But what about the, the fallout, not fallout in the 1950s sense, but all the radiation and nucleotides that you unleash into the void. And not to mention all the particles. I mean, there's enough space junk above us anyway.
Right.
Although the explosion occurred right near the moon, 200,000 miles away, I guess, 150,000, not much after the moon, I guess.
Uh-huh.
It's not near Earth orbit they did it in, but still, I don't know.
I
There's a
like
lot of space out there.
Well, there is, but some of it lands in your backyard. I like the idea of giving it a nudge and changing its
250,000,
trajectory.
230,000 miles away.
I always love this animation about
You wanted to give it a nudge?
Yeah, that's my ideal.
What is this animation you're showing?
Oh yeah, this is just like a quick scale of the Earth towards the moon. Like, so if we were to blow up something by the moon, we'd barely even notice it because it's so far away in comparison. Yeah, geosynchronous satellites. So these are the farthest satellites to orbit above Earth, is in this blue ring. And then the moon is all the way over here. That's to scale. Yeah, I didn't even get to my little PowerPoint. But the first thing I wanted to talk about was thinking about a real life situation in which Earth could encounter a meteor that would spell huge trouble for us if it struck the Earth. And surprisingly, after watching this video, it's a really brilliant video released quite recently. How long ago was it? Only 5 months ago. Says that these gigantic meteors, they're not technically meteors until they enter Earth's atmosphere. These asteroids, I should say, the ones that are really huge and noticeable.
What's the difference of an asteroid and a meteor again?
So a meteor is when that asteroid is now into the Earth's atmosphere and is burning up. So a meteor is that glowing trail that you see soaring across the sky. So it becomes a meteor when it starts burning up. And it's just an asteroid basically when it's floating around in space. And yeah, this is a really cool video that kind of explains it. Let me know if you can hear it, because I know we've had audio problems.
This is the one in Russia.
Mm-hmm. You can't hear it, but they have captions.
So an asteroid, a meteor becomes an asteroid.
The other way around.
No.
An asteroid becomes a meteor.
Right.
Okay.
Well, it's still floating in space. It's an asteroid.
Mm.
So I've always wondered about meteor showers and satellites, things that are up above us, even airplanes. Do planes ever get hit when they're flying through a meteor shower? The Geminids, whatever.
I think most meteors burn up much higher than planes fly. So planes fly about 7 miles above the Earth's surface. Meteors usually burn up about 50 miles above the Earth's surface. So when you see the meteor showers, they're like
Yeah.
7 times higher than aircraft.
Uh-huh.
Wow.
This is how that's,
On the moon.
yeah.
Wow.
Was it just reading about some meteors or conglomerates, and it has a fancy name.
How would he have found that?
I think it tells you.
But you can't, okay.
We can't hear it.
Well, we can read it. It's captioned.
Ah.
Wow, that's pretty intense to think about. And then there's a business about Jupiter saving us from a lot of asteroids
That's right.
because
Yes.
it's
How is
gradu-
that?
gravitational force brings them into its rings.
Mhm.
Mm-hmm.
Wow.
Oh, there's the Bethesda fountain. Hello.
Hmm.
Gonna crush the Bethesda fountain?
Hmm.
Do you think the asteroid belt could coalesce into another planet?
Um, I don't think so, just because they're all moving sort of with the same angular momentum.
Uh-huh.
They're all like chasing each other.
Mm-hmm.
Fascinating. Hmm.
Are the asteroids influenced by the gravitational forces of the different planets? And
Yes. So I'm gonna just show you one more thing with this video because I don't want to go the whole 20 minutes. But yes, all the asteroids are influenced by everything in the solar system. Mainly the sun, just because the sun accounts for 99% of the mass of the solar system.
Mhm.
And that's the reason there is an asteroid belt. They all formed in that belt because they're all being influenced by the sun, that they're all orbiting the sun. Jupiter has the next largest effect. And I think there's an even more detailed animation of the asteroid belt. The Trojans and the what are the other ones? The Greeks, the Trojans and the Greeks. So yeah, this is like a tiny image. Let me see if I can maximize it. Okay. So all these white asteroids form the main asteroid belt. And then there are these Trojans that trail behind Jupiter and Greeks that are in front of Jupiter, and they sort of share Jupiter's orbit. And I think these are called Lagrange points. These are where you could think like a gravity well. Jupiter would be like sloping downward, and the little mass sitting at the bottom of the well, Jupiter would be sitting at the bottom of the well.
Mhm.
Where these asteroids are located in green are sort of like the flat parts where you can be nice and stable. And the reason they collect in these two regions, the green regions, is Jupiter's gravitational influence.
Wow.
So
Mhm.
Jupiter is pulling on lots and lots of asteroids. And we kind of owe our existence. We're not getting railed by lots of asteroids because Jupiter's helping us out.
Where's Saturn in this?
Farther
Saturn
out. Twice as
is
far.
outside of the picture.
Okay.
Yeah. Saturn you can think is like twice as far away from the sun as Jupiter.
Got it.
But does Jupiter have an effect on all the white asteroids there?
Not as much, not nearly as much as the sun does. A little bit, some of them, but not nearly as much as the sun does.
It almost looks like they're in a gravity balance between the sun and Jupiter. And
Yes,
yeah.
essentially that's what it is. Yeah, so yeah, I was right. These are Lagrange points.
Lagrange points means what?
You can sort of think of them as like parking spots. So if you just like sit there and don't do anything, you won't get drawn into any planet or the sun. You'll stay there. You'll stay in a nice, stable orbit.
That's where the James Webb is going, into L1.
Mm-hmm. Yeah.
A million miles
5,
away from here.
Exactly.
So
there
it'll
are
be
5
that
Lagrange points.
it'll be further than the Hubble.
Oh, the Hubble's only 5,000 miles, 1,000 miles away. I don't know how far, but this is a million miles away. James Webb will be.
Oh, so this is a gravitational well depiction?
Yeah, Hubble Space Telescope is 350 miles. above Earth. So yeah, these are Lagrange points for the Earth. And I think this is for any planet with a single satellite. So you have 1 and 2, which are like the foci. Actually, no. How do I want to explain this? You just think the sun has its gravitational well and the Earth has its gravitational well. Now the sun's is much deeper than the Earth's, and the Earth is just like a tiny pocket up here. But then there's like a little saddle point in between the two wells where it's flat. The derivative is 0. So there's no
So-
slope.
L1.
It's 1,000,000 miles away from Earth and 92 million miles away from the sun.
Perfect. Yes, I think that's right.
Mhm.
And so that's the little parking spot. You're kind of like sitting on a little ridge where it's flat. If you move one way or the other, you're going to fall towards
Right.
Earth, or you're going to fall towards the sun.
Right.
So it's where the gravitational pull is equal in a
Right.
way.
Yeah, you're being pulled. That's a great analogy, Deborah. You're being
Yeah.
pulled by Earth the same amount you're being pulled by the sun.
And so what's L2?
L2 is it's either you fall into the Earth one way, or forget which way you go. I think at that point, Earth's gravity is like weak enough so that it kind of levels out at that point. And so note that this is far beyond the moon's orbit. So it's sort of like the last bit of point of no return. You can think of like a waterfall. If you get too close to the waterfall's edge, you're going to fall into it. But if you stay far enough back, you'll be okay.
So I would think, so where is the web going to be, at L1 or L2?
Let's see.
You would
L1.
think you would,
L1.
it's curious. You would think you'd want it on the dark side of the sun at L2.
Well, maybe you're right. I thought it was L1.
Looks like it. Yeah, L2 might be
Right,
the next
L2.
home.
Oh. I mean, I'm
Maybe
just looking
L2.
at the picture and thinking, that's all.
That's good. Smart.
Got it.
So L2 is a balance between the Earth and the rest of the solar system,
I think that's right. Yeah.
gravity. So you'd
Right.
think it would be very asymmetrical.
Yeah, because
And there
the
it
planets
is.
aren't
Yeah,
always
yeah.
aligned.
Right, they're not always aligned, and a bunch of them at great distance is not the same as one big sun on the other side.
Right.
But
Yeah, you can kind of average out all of the planets and say,
yeah,
you know, at some distance, you're going to be pulled in by something instead of the Earth.
yeah.
But
So it would vary a lot, as you say, because of the orbits.
exactly, yeah.
Yeah. Hmm.
Well, it's interesting because this woman gave one of those stargazing talks a month ago, and the issue came up that right now the idea is that, you know, the Hubble we had, which is only as we just found out, 350 miles away. We've been up there 4 or 5 times to fix the hardware. There's no plan to go to L2 right now. So that's why the idea is it's, one and done. And I guess any of the updates would be software updates, of which you can do a lot, but not hardware. And then I said, well, what happens in the 1 in a million chances that the hardware goes bad? She says, well, maybe then we'll figure out some way to go send some robotic something out there, that's necessity is the mother of invention. We'll figure it out then,
Yeah.
I guess. Like send some robotic something. You probably won't send asteroids out there to fix the hardware.
No,
Not astronauts, I mean, to fix the hardware.
astronauts, yeah.
Yeah, we're going to send robotics probably if we had to fix it.
But since we're working on going to the moon and Mars, we're working up to it.
Yeah, maybe someday astronauts would go up there on their way to Mars and fix the James Webb or something. I don't know.
Yeah. So I had a question about the way they depicted the asteroid with all of these spicules, and because I think of asteroids as the pictures that we, the photos or depictions we've seen.
Yeah, I had the very same thought. Are you able to see this? Oops.
Yeah.
Yeah,
Can't hear it.
Well,
see it.
1 second.
Oh.
I gotta accept this tab.
we can see all sorts of things. Please,
This little menu keeps bugging me.
Meteor showers all the time. Yeah, right now it's the Lyriads, I think. Of course, right now it's raining.
Yeah.
Whenever there's anything good, is when
Okay.
it clouds over here.
We can't hear it, but we can see it.
Yeah, all of these like gases that are like spewing out from the surface, I really didn't understand.
Yeah.
Yeah, they had, yeah.
Did that have to do with the kind of volcanic or earthquake type action going on in the
Asteroid.
asteroid?
They talked
Yeah,
about earthquakes.
Yeah, there were like earthquakes, and there was like this methane pocket that had exploded.
Mm-hmm.
Yeah.
Trying to move this tab. Get rid of this thing. Oh, there we go. Okay, that's a lot easier.
We've landed JPL had that whole thing a few years ago where they landed something on a comet, but have we ever landed anything actually on an asteroid before?
Yeah, just like it within the month.
Yeah.
Oh, we have?
Yeah.
Who,
I
JPL?
don't know. Speaking of J, I think it was the Japanese that did it.
Water, apparently. I think it's like liquid volatiles of some sort. So remember we were talking about like cryovolcanism on Europa and Enceladus.
Mm-hmm.
Mhm.
I think that's kind of what they're trying to mimic here, coming out of an asteroid. But I'm really skeptical that you could have such a thing, since asteroids are far smaller in comparison. They wouldn't have all that heat and pressure built up underneath the surface. So I don't know.
Well,
I think it kind of is a little bit crazy.
what about all the fires? Where's the oxygen to fuel those fires?
Yeah,
So-
yeah, that's another point I was going to bring up.
Yeah.
All these like sparks that are flying
Yeah.
when they're like
Yeah.
getting knocked around by the asteroids. And I was like, this is classic Hollywood. You can't have this many explosions going off and all these sparks. I think it's just adding to the level of drama. There is one interesting video I found. I'll just show you this real quick. Only like a few seconds.
Well, if you had some other oxidant besides oxygen,
Mm-hmm. What was that?
if you had a different oxidant,
Yeah.
rather than oxygen,
Uh-huh.
you could still, have the chemical exothermic reaction, right?
I think so. But one thing that I kind of just made a connection to is like,
Oh, Semtex. Oh, look at this.
yeah, here's a real explosion, a plastic explosive. This is what it looks like on camera.
Come on, run.
Barely anything. Hold on. Just a quick blip of light and some smoke. Most of it was just noise. So here's what movies make it look like.
Cool.
So yeah, that's just a
So
bit of
that's
Hollywood
the movie
effect.
version, which I think
Right.
they use a lot of some, I don't know what. So can you go back to what the Semtex looked like?
Well, this
Yeah.
I
is,
didn't
you were
even
trying
see
to
it.
show us what the dinosaurs would see 1 year before.
Yes,
Yeah.
I'll get back to that. But yeah, here's what the regular explosion looks like. I think they showed a couple times.
That's a big chunk of Semtex.
Mhm.
So that was it. So there was an explosion.
Yeah, it was just so brief. The part that you see was so brief.
So I don't know, where in my paying attention to Hollywood gossip I heard this, but that a lot of the explosions are done with gasoline. 'Cause
That's
it
right.
makes
Yeah.
these huge billows.
Yeah. So not only that, but they have like little funnels that shoot them out in like all directions.
Ah,
And yeah, so here, this bag is being mixed with jet fuel, gasoline, and diesel.
ah.
And now it's gonna like propel the flames. So they do a lot of different techniques to like throw the fire all over the place.
Ah.
Yeah. The last thing I wanted to show, which is probably the most interesting thing, and I kind of saw this just on my own. It had nothing to do with the movie.
Yeah. Yeah.
What the dinosaurs would have seen. So here, we'll go to 1 year before the impact. So 1 hour, 1 day. Let's go back. Okay. So there it is, just a little dot.
Mm.
So they're using comet and asteroid interchangeably. Actually, we started with this. So but the
Yeah, comets
composition,
just have some ice and that's what gives it its tail.
yeah. But asteroids don't.
Asteroids don't have any ice. So we'll go to the last 5 minutes or so. So it shows various angles from the comet's point of view, from the moon, and then from Florida and France, I think.
Well, I was very upset that they wrecked Paris in the movie.
Hey, what about Paris?
They wrecked
That's where-
Paris.
Oh yeah, in the movie. Yeah, France. This is what it would look like a few minutes before impact.
Oh, who created these photos?
Whoever made this YouTube channel, just like computer simulation.
Got it. Okay.
So now you can kind of, this is now a couple minutes before impact. Once it passes through the atmosphere, all the heat is now felt by anybody standing on the ground, and the whole sky turns white.
So it's okay to go to Florida for the launches. It's not a good idea to be in Florida for the impact, right?
Yeah, right. Ryan, I'm just thinking of a set of YouTube videos for you to see about tectonics.
Mm-hmm.
Let's go teasy.
And there it is. Everybody gets vaporized in a second. So then they have the real-time aftermath.
Mhm.
So crater impact looks like almost 10 kilometers deep. And then almost 60 kilometers across the crater.
Wow.
But yeah, so that was the last slide. What did the dinosaurs see just before their great extinction 67 million years ago?
That's my idea.
Yeah.
Wow.
Oh, actually, wait a minute. What are you? Okay.
Well, I guess the way Bruce Willis died, he went out like a hero. So
Yeah.
The question is not how Bruce Willis died as a hero, but how the heck did the others get away from it?
you mean
Ah.
in 1 minute on that shuttle, or
Oh,
2 minutes?
yeah.
They had 3 minutes. Get away.
Oh, they had 3 minutes? No problem. No. But how did the others survive that process?
They were on the shuttle. The shuttle took off 3 minutes before he,
So
you
it,
know,
the
he
shuttle
detonated.
outran the shock wave and all of this.
In 3 minutes.
Wonderful. Yeah.
Well, it had to not only outrun the shock wave, but it had to outrun the particle
The
fallout
debris.
and one
Yeah.
or the other of the split asteroid and whatever else. I don't know. Any thoughts?
Well, maybe they had a plutonium engine.
Perhaps.
Tell you, I thought it was pretty, the way they depicted that asteroid, I thought it seemed a little unrealistic that shuttle could even launch off the asteroid.
Right.
You needed some, I guess, well, we've never really seen a shuttle take off, have we? Space shuttle isn't made to take off, is it?
No, it burns the shuttle burned its fuel on the way up.
Yeah.
It was a glider after that.
Yeah, so I don't know how they got, that was a big jump to get the shuttle to take off from that asteroid.
Yeah. And the other, what they,
What you needed is a good Russian to go down there and hit it a few times to get it to work.
All you need is a what, honey?
That Russian guy that kept knocking everything to make it work.
I love that actor.
Yeah, he was great.
Yeah. I think these guys had a lot of fun and they knew it was ridiculous, but they just went for it.
Well, what made the movie great was the level of comedy, the whole thing. I mean, it just had a wonderful level. And plus, the actors were great. I mean, those are actors that Ryan, the three of us have followed a lot of those actors during their whole career. So.
Oh, really?
Yeah.
Yeah.
Nice.
Yeah.
About 6 of them.
How much did this movie cost?
It was 140 million to make it, and they made about $550 million in gross revenues.
And
We
back
first
in that
saw
day,
Bruce Willis in Moonlighting
Mhm.
on a television series.
Mm-hmm. Yeah, with that woman who kept saying, Bruce
Sybil-
Willis, I'm the star. What was her name?
Sybil Shepherd.
Yeah.
Yeah. I'm the star and he's getting all the PR.
Right.
Yeah. Even though he's losing his hair. Yeah. Ugh.
Huh.
So Ryan, what's next?
I haven't decided yet because that was the list I had come up with like 3 weeks ago. So I gotta come up with a new list now for future episodes. I'll let you know probably tomorrow, if not definitely by Monday.
Sure.
Good.
Okay, so this is Friday.
Yeah, no later than
Yes,
Monday,
it
because it takes me 2 days to watch. Takes us 2 days to watch it Monday night.
Right.
Yeah.
Yeah.
Yeah, me too. And Sunday there's a speaker series thing.
Mm-hmm.
right.
Okay, Ryan, go to bed. You're exhausted. It's 11:20. Go for
All
it.
right. Take care, you guys.
See you next week.
We will.
Hello. Bye, guys.
Bye.
Stuart, Noanne. There was
Yeah.
something I was